Imagine a world of no more privacy, where your every purchase was monitored and recorded in a database, where your every belonging was numbered, where someone many states away or perhaps in another country had a record of everything you had ever bought, of everything you owned, of every item of clothing in your closet, every pair of shoes. Imagine a world where even people were numbered and tracked at a distance. My own thoughts about privacy led me to begin researching the issue about 4 years ago. In 1999, I became concerned about supermarket and grocery store cards, the seemingly harmless loyalty cards that you began getting asked for in the early 1990s in order to qualify for discounts at the supermarket. What I learned was that those programs were essentially registration systems that were taking all of our food purchases that we made at the store, linking them up with our names and our personal identifying information, and storing them in databases. Since 1999, when I made that discovery, I have spent the last 4 years of my life deep in research about tracking and monitoring programs involving retail spaces, buying and selling, and purchasing. And the world that I just described, where your every belonging is cataloged in a database, may not be that far off. If we move to a world where your every belonging is in a database and can be tracked remotely, which is what we'll be talking about in the next hour, we will also move to a world in which your every move can also be tracked and monitored remotely. Let me first start by talking a little bit about my background and the supermarket grocery card issue and how it has paved the way for what will ultimately be one of the most invasive things I believe the human mind has ever invented when it comes to privacy. In the early 1990s, grocery stores hit on an idea that if they could find a way to offer you something special in exchange for shopping at their store, that you might be more likely to go there instead of to the competitor. So in the early 1990s, a couple of grocery stores got started printing up little cards asking you for registration information. And when you filled that out and you went to the grocery store, you qualified for actual discounts. And those discounts would be above and beyond the regular supermarket discount of the regular items on sale. And it worked pretty well for the first couple of years. And then what happened was that other stores began getting on board. And then the database folks got involved. And they started telling supermarkets, listen, you need to go to the next step and you need to begin actually monitoring what people buy over time. Because by doing that, you can identify who your good customers are and who your maybe not so good customers are. So what happened was these grocery store cards became linked to incredibly detailed databases of information, to the point where now oftentimes those databases of information will contain what they call, the supermarket can buy something they call a penetration profile, which includes additional information about you, not only what brand of orange juice you buy or how often you buy toilet paper, but they can also buy information such as how much your home mortgage is, or your auto insurance record, or the type of car you drive, or even your dress size. Once that information began getting collected in these large databases, the databases began growing and growing, to the point where now these databases are absolutely enormous. The card programs, the food purchase registration programs is what I call them, have now spread over the entire globe. The last I heard, a program was going into the nation of Yemen in the Middle East. So they have truly become international. They operate a little bit differently in different countries. In some countries you get points or rewards, sort of like the old-fashioned S&H green stamps. Here in the United States, though, the model is still a two-tiered pricing program where if you don't comply, you pay a higher price. What we found through, or what I found through my research in the last couple of years, is that very coercive tactics were used to get people to sign up, such as in some cases doubling the price of certain grocery items if you didn't have a card, and leaving the price at the manufacturer's suggested retail price. In other words, no discount at all, even when you did present a card. We found that the prices at card stores are higher, and we found a whole host of problems with these programs. But nevertheless, what has happened is over the last 10 to 13 years now, about 80% of American households now participate in some form of purchase registration program through those cards. Now, in the course of doing this research, last year I was asked to write an article for the Denver Law Review. And they said, what we'd really like to know is what are the privacy implications of having purchases monitored and registered in databases? What really does that mean, and how deep does that problem run? And in doing that research, I spent about 3 months reading very esoteric industry journals, reading retail industry journals, reading electronics journals, reading anything I could get my hands on to try to answer that question of how far does the surveillance and registration go. And I stumbled across something in the course of doing that research that absolutely made my hair stand on end. And that something is what we'll be talking about tonight, radio frequency identification. Now, at the time that I stumbled across this about 1.5 years ago, it was the radio frequency, and I'll be explaining what it is, and I'll try to be non-technical tonight because it can be a bit of a technical concept. At the time that I stumbled across this in doing research for this other article, it was not known really by anyone that this was happening. Only a handful of engineers at research institutions like MIT and the, of course, global corporations that were funding it and were behind it. And let's see if we can do our first slide. What I discovered was that out of MIT, the Massachusetts Institute of Technology, that's based out of Boston, Massachusetts, and it's where we get some of our best engineering and mathematics and science minds get trained at MIT. MIT had hooked up with Procter & Gamble and Gillette to create something called the Auto ID Center. Auto meaning automatic, not automotive. Auto ID meaning automatic identification. And what the engineers and scientists at MIT, Procter & Gamble, and Gillette got together to do was to take an existing technology using radio waves, similar to the radio waves that communicate with your radio, and use that instead to communicate items or physical objects to the Internet. Now, in 1999, when they formed this organization to do this, they had very little funding. They had what many considered to be a pipe dream that would be almost impossible to fulfill. They had some huge technical hurdles ahead of them to overcome. They have overcome them, and in a very short period of time, and in a way that is actually quite extraordinary. What they have developed is a system to literally number every physical item on the planet Earth with its own unique identifying number. The way the system works is they've developed something called an EPC, EPC standing for Electronic Product Code. Some of you may have heard of the UPC, that's the formal name of the barcode that we see on products introduced in the 1970s on a broad scale. The barcode, UPC, is the Universal Product Code, and we are now switching to the EPC RFID chip code. Now, this image here shows the tiny silicon chips, and what you're looking here is at a dime, and together with that is a little vial filled with water, and what look like tiny specks of glitter or dust. They're incredibly small. In fact, let's see if I can, this particular chip here is only 0.4 millimeters across, and you can see it compared with a grain of rice. That's a chip produced by Hitachi, which is currently the smallest of these chips in the world. And now let's talk about what they do. Each of these chips contains an EPC number, or a unique identifying number, different from every other chip. Now, you can think about them in a way, they've been referred to as tiny computer chips, but when we think about computer chips, we usually think about something that does something, maybe performs some calculations. All these really do is store data, and the data that they store is their unique identifying number. That number can be, let's say 96 bits. That's one of the possible numbers proposed for this. 96 bits, not to be too technical, would be a series of 96 zeros and ones. And to put that in perspective, I've been told that with 96 zeros and ones, you can have enough combinations of unique numbers to number every grain of sand on the planet Earth. So it actually is quite feasible to use 96 zeros and ones to number every item on the planet. Now, the next question is, well, what do you do with numbering every item on the planet, and why would anyone want to do that? Well, the RFID chips themselves, these tiny little devices, in and of themselves, even if you did